à tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage P80 et décollage. La propulsion est nominale. Paramètres à bord normaux.
And we're off. Sentinel-2B is on its way. Look at Vega.
Les paramètres à bord sont normaux, la trajectoire est nominale.
Blazing a trail across the equatorial skies over the Guiana Space Center, heading north out over the Atlantic. We're just getting the rumble, the sound, if you like, of the launcher here at the Mission Control Center. The job of the first three stages is to get us away from the Earth. Vega's pushing itself away from gravity. And we're burning the first stage. It's called the P80. That's because 80 is standing for the amount of propellant, 89 tons in fact. On the bottom left you can see our altitude is 35 kilometers above Earth. And in the middle, our distance from the pad. That's actually the distance if you were to draw a straight line from the pad to the position of the launcher along the Earth. And then on the bottom right, you can see is our speed. We're travelling nearly 2 kilometers per second, not per hour, but per second.
Acquisition de la télévision lanceur par la station de Saint-Jean. Séparation P80.
We've
Allumage du VV09.
Separated the P80 and lit the engine now on the Z23. And joining me in the commentary box here is Guido Levrini. Guido is the Copernicus space segment program manager for ESA. That means that he oversees all the Sentinel satellites. It's great to have you with us. Thank you very much indeed, Guido.
Thank you for having me.
Guido, you also know quite a bit about Vega. And although it was developed by ESA, it actually started out as an Italian project, didn't it?
Not quite, not that completely. Vega grew out of a joint cooperation between the US and Italy back in the 70s. It was a project called Scout. It was launching from a base off the coast of Kenya, near the equator. And at a certain point in time, in 1992, the US withdrew from this cooperation, and the Italians continued alone on a new program called Zefiro. And Zefiro in Italian is a name of a wind, and it was based on the carbon fiber technology. And Vega, which in Italian stands for Vettore Europeo di Generazione Avanzata, or Advanced Generation European Vehicle, is a launcher developed by the European Space Agency. So it's an ESA project, but you're right, the prime contractor is Italian, is ELV, which is a joint venture between the Italian Space Agency and Avio, who is a company based in the south of Rome.
Now, right now, we are flying like the wind, burning the Z for Zefiro, second stage, and now about to switch on the Z9, Zefiro-9. My pronunciation is probably a bit wrong. I think it's Zefiro in Italian.
Zefiro.
And the next phase, separation of the fairing, which we don't need anymore because we are 131 kilometers above our planet, and we don't need it because there's hardly any friction. Vega's going from strength to strength. Let's hear from the CEO of Avio.
Vega has set a world record in terms of accuracy and reliability, with 8 perfect launches in a row from the maiden flight in February 2012, exactly 5 years ago. Vega has demonstrated a unique ability to deploy satellites in multiple orbital planes with unprecedented orbital maneuvers. Vega is the smallest of the European launchers family operated by Arianespace. Vega was developed by Avio as the industrial prime and is manufactured at 65% in Italy, and for the rest across Europe by a team of selected and capable industrial partners. I'm speaking to you from our plant in Colleferro, where we produce Vega, and we are now developing Vega C, which will fly for the first time in 2019. Behind me, you see the production of the first carbon fiber motor case of the P120C, the solid rocket motor which will equip both Vega C and Ariane 6. This will be the world's largest monolithic solid rocket motor manufactured in carbon fiber. It is nearly 12 meters long, has a diameter of 3.4 meters, and contains 142 tons of propellant. Today, Vega will take to space Sentinel-2B, one of the satellites of the European constellation Copernicus. The Avio team, together with its industrial partners, Arianespace and the European Space Agency, have once again a chance to demonstrate the strength of Europe's space strategy, which hinges around our close collaboration and teaming. I therefore wish the best success to the 9th mission of Vega.
Par la station de Saint-Jean.
Interestingly, the carbon fiber that he mentioned there was used in a spin-off to build some great big structures inside. We have separation of the Z9 inside ITER, which is a nuclear fusion experiment. So our flight path, Guido, takes us north. Where are we going to be flying over?
We are actually flying at the moment over the Caribbean, and we will soon go over Canada, then over the Arctic, and then we will come down on the other side of the Earth. We will coast let's say, East Asia coast, and finally we will go over Australia, where we will separate our satellite. This will happen 58 minutes into the flight.
And the range operations manager is confirming there that we picked up the signal at the Bermuda tracking station. That's in the Caribbean, one of the Caribbean islands in the north of the Caribbean. So we are now flying over the Caribbean. Why are we flying north, Guido?
Sentinel-2 is an Earth observation satellite, and this satellite are usually placed on an orbit that goes over the poles. This because, being on such an orbit, you exploit the rotation of the Earth underneath to image the whole Earth. You have to imagine that you're peeling an orange, and stripe after stripe, you are peeling it completely. And these stripes, in the case of Sentinel-2B, are very, very wide, almost 300 kilometers, and this is what allows us to image the whole Earth with one satellite every 10 days, and now with two satellites every 5 days. And at our latitude, our meaning European latitude, every 3 days. There is no other system in the world that has this performance.
Premier allumage de la VV09.
So, Avon, the upper stage, has switched on its engine. That's going to burn for 7 minutes. So we've started the next phase of the journey because Avon has effectively taken the wheel, as it were.
Yes, it's his job now to deliver the spacecraft to the drop-off points at almost 800 kilometers. But this will go in steps. This will happen only in about 15 minutes from now.
And Avon has started what we call the orbit-optimized guidance attitude.
Yeah, it continually recalculates the position to make sure it's on the right track, and of course it deviates, corrects the position.
Sentinel-2B is on its way to join its twin. Together they will perform an important mission.
Noordwijk, the Netherlands. In an ESTEC cleanroom, the final preparations are being made for the transport of the Sentinel-2B satellite to the European Spaceport in Kourou, French Guiana for launch. When in orbit, Sentinel-2B will join its fellow Sentinels and start to play a vital role in Europe's Copernicus program. Copernicus aims to provide timely, accurate and easily accessible information to monitor our environment, better understand climate change and mitigate its effects while ensuring civil security. The launch of Sentinel-2B will be another step in the deployment of the most ambitious Earth observation program ever developed.
Sentinel-2B is the fifth Sentinel which is being launched. We have 4 Sentinels launched already since 2014. Altogether there will be 15 satellites plus 5 instruments flying on other satellites of EUMETSAT. So we have a constellation of 20 satellites in its first generation, which we are building up. So Sentinel-2B is number 5 in this very successful story.
Sentinel-2B's identical sister satellite Sentinel-2A was launched in 2015, and soon both satellites will fly in the same polar orbit 180 degrees apart. This will ensure that every spot on Earth can be covered in high resolution by the satellites at least once every 5 days. Sentinel-2 carries a wide-swath, high-resolution multispectral imager that provides images in 13 spectral channels. This optical data is then sent back to Earth, where this valuable data is being distributed.
Sentinel-2A is already supporting a lot of applications. They're ranging from, for example, agricultural applications where we can do yield forecast, to forest monitoring where we, for example, see deforestation. And besides that, there's plenty of other applications like inland water, where we can look at the quality of the water. We can support river monitoring, but also coastal areas, where we look at the changes in the coastal regions. On top of that, we recently changed also to acquire the Antarctic region, so we're also now looking at ice and glaciers.
Whether it's vegetation monitoring, deforestation, water quality or flood monitoring, the impact of the Sentinel-2 mission on everyday life is growing, impacting the lives of millions of citizens. It can also be used for humanitarian relief efforts in the event of disasters. With the launch of Sentinel-2B, the amount of data gathered and fed to these applications will double. The Sentinel-2 satellites are the result of a close collaboration between ESA, the European Commission and the European space industry.
Sentinel-2 is a spacecraft which harnesses many competencies and talents from the European industry. The prime contractor is Airbus Defence and Space in South Germany, located in Friedrichshafen. And I would underline as well the payload instrument designer, which is Airbus Defence and Space in Toulouse. But underneath those two major industries, you find about 55 companies who have produced the various elements that compose this very performing system: hardware, software, test facilities. All of that is very important to be able to deliver the high quality and performance mission, which is the one demonstrated with the first spacecraft in orbit.
With the Sentinel satellites and the Copernicus program, the European Space Agency ESA and the European Commission continue to work on monitoring and protecting our planet and the people who live on it.
And during that film, we picked up the signal that the Saint-Hubert or St. Hubert tracking station, that's in northern Canada, and we're tracking the launcher using telemetry. And for anybody who's unfamiliar with that, Guido, what does that mean?
While the launcher is following its path, it's tracked by radars, but it also sends continuously information on the ground, signals on the ground on the state of its equipment on board. And this is what we mean by telemetry.
And those tracking stations send the information that they've collected from the launch vehicle here to the CVI. The CVI is the Real-Time Visual Control Center here at the Guiana Space Center. And the teams collect the information and analyze it in real time to check how the flight is progressing. And they also analyze it to check how things went afterwards to see if they can make any improvements.
And these are the people that pass the information to the range operation manager, who is sitting here in the mission control, and he announces this confirmation of the major event to all of us.
Flying now at nearly 8 kilometers per second, our speed on the bottom right.
Du lanceur par la station de Bermude.
And on the top right-hand corner, our trajectory.
Moins de 30 secondes de propulsion pour le premier allumage à Vouma.
So Sentinel-2A was launched 2 years ago, and of course 2B is on its way to join it, Guido. Why do we need a couple of satellites, briefly?
We need 2 satellites because Copernicus is all about delivering an operational system. It's an operational system, so you need robustness. And it's all about, let's say, constant monitoring of the Earth. And to achieve that, you need a high revisit, as we call it, which means you have to pass on the various places of the Earth more often, very often. And you achieve that with 2 satellites.
And we now have switched off our engine. The AVM upper stage has switched off its engine, and we have entered what's called the ballistic phase. He's just told us that we've started the orientation before the ballistic phase. And everything's going according to plan. So why did we switch the engine off now, Guido?
So now the big first boost of the AVM has finished. It has placed our satellite and the AVM on an elliptical orbit, and we are now raising our altitude on this elliptical orbit up to the final orbit, which is just below 800 kilometers. And at that point in time, we will circularize our orbit. We will switch the AVM off on again. So at the moment we are heading up, following the laws of physics.
And here we can see the teams at ESOC, the European Space Operations Center. That's in Darmstadt in Germany.
Yes, these are our colleagues that will take control of the satellite as soon as the satellite will be separated. And will control the satellite for the rest of its lifetime, which is quite long, is 10 years. So they are very tense. The moment of action is coming soon for them. And this is the control room, the mission control room, but next to the mission control room, there is also a big social event. And we'd like to take this opportunity to send our greetings to all our colleagues there. There are startups, small companies, students, academics, Earth observation experts, the media. And if you want to follow the debate, remember, hashtag Sentinel-2Go. Hashtag Sentinel-2Go.
And you can take a look at that and join the debate on the social media networks. Also, Guido, you've been telling me about an app, and I want to tell everybody about this because it sounds quite fun. What's it called and what does it do? Just a replay here. We lifted off about 17 minutes ago from the pad here at the Guiana Space Center, and beautiful launch. And you were going to tell us about your app, Guido.
Yes, I invite everybody to download. It's free from their store, an app called ESA Sentinel, so ESA, like European Space Agency, Sentinel. And you can see in real time where the various sentinels are located in the sky. And if you do that when we are having our break, I invite you to locate Sentinel-2B on the app. This is your challenge.
This is your challenge, your mission ahead. We, as you say, are going to take a break now because we have a ballistic phase. We're going to come back to you in about 23 minutes' time, 23:31 Kourou time. See you then.